percent composition. When we talk about percent composition in chemistry, we talked about how much is the percentage of a certain component that makes up a certain pure substance. So in other words, when we talk about percentage, it's always the part, the component you're looking for divided by the whole, which has to be multiplied by 100 for you to get the percentage value of that particular part. For elements in a compound, so when we have a chemical formula of a compound, we need to remember that we need to get the percentage of that particular element, you need to get the percent or the mass of that particular element divided by the molar mass of the compound. Where do we get the mass values? We get it in the periodic table. So it's always the mass of the component you're looking for divided by the total mass of the compound. Then after dividing, we have to multiply it by 100 to get the percentage of that particular element. So let's illustrate that percent calculation in chemistry to 3 examples here. So let's start with a basic example about water. So we know that water comprises of 2 elements, hydrogen and oxygen. And here you're given the structure, the bent structure of your water, which has an angle of around 104.5 degrees because water has 2 lone pairs. So let's solve for the percent hydrogen and oxygen in water molecule. Before we start with that, let us first know the mass of these elements. So we know that your hydrogen in H2O, there are 2 of it, and then there's 1 oxygen. Then we look at the periodic table, the mass values of hydrogen is around 1.01 and oxygen is around 16. So let's multiply so that we can get the total for each element. So for hydrogen, 2 times 1.01, you get 2.02. For oxygen, it's 1 times 16, so that's just 16. So we have a total of 18.02 grams per mole. This is the molar mass of your water molecule. So 18.02. This is what we call the total mass of your compound. So how do we now get the percent hydrogen and percent oxygen from this? So plainly, all you need to do is for percent hydrogen, so percent hydrogen, it's just that you get the mass of hydrogen. So the mass of hydrogen in H2O is 2.02 grams per mole divided by the total mass. Total mass is 18.02. I didn't put already the units because the units will cancel out because we're dividing. So both have the units of grams per mole, so no need to put a unit. And then we multiply it by 100. Putting them in the calculator, you will get around 11.21% of hydrogen. So this percentage will tell us that hydrogen comprises 11.21% in the compound of water. Let's go to the percent of oxygen. So percent oxygen is same thing. You need to get the total mass of oxygen in H2O, which is 16. So that is 16 divided by 18.02, then multiply it by 100. So putting that in the calculator, we will get 88.79% of oxygen. So looking at the answer, 88.79% for oxygen and 11.21% for hydrogen, you will get a total of around 100% for the entire thing. Because you're getting the percentage of all the elements of the compound, it makes sense, it's logical that the total percentage of all that element should sum up to 100%. So these two are the correct answers to get the percent hydrogen and oxygen in your water molecule. Now let's go to the next example. This is about the example of your chalcopyrite. It's a mineral that constitutes iron, sulfur, copper, and some other elements. So in this case, what is the percent copper if you have 8.33 grams sample of chalcopyrite that contains 2.88 grams of copper? This time, you're not given the chemical formula, but right away you're given the sample. So we can safely assume that your 8.33 grams of sample is already your total mass of your substance, and your 2.88 grams of copper is already your mass of your component copper in the compound. So plainly, if you want to get the percentage of copper in this case, all you need to do is percent copper is equal to the mass of copper divided by the total mass of the sample times 100. This is the same expression. Then substituting it, it's going to be 2.88 grams divided by 8.33 grams, in which your grams will just cancel out, and then multiply it by 100. So in this case, you will get 2.88 divided by 8.33 grams. In two decimal places, you get 34.60% of copper. So this is the percentage of copper in your 8.33 gram sample of your mineral chalcopyrite. So this is how you handle this if, for example, the problem will give you sample of substances without the chemical formula. And lastly, another example is about the antacid. Antacid, in this tablet shown in the picture, you have 100 milligrams, 105 milligrams as its mass. So it's like your tablet is your sample, and it contains magnesium carbonate. But your magnesium carbonate in this tablet has 28.8% magnesium. How much is the mass of the magnesium really in your 100 milligrams tablet? So the approach of this problem is kind of tricky because you're given already the percentage of magnesium, 28.8%, in your 105 milligrams of sample, in which, because this is the sample, it's safe to assume that this is the total mass of your substance. So how do we make use of these two given in order to get the actual mass of magnesium in the tablet? Let's make the expression, the percentage expression, to get the percentage. So percent by mass of magnesium will be expressed this way. It's mass of magnesium over total mass times your 100. Now, let's substitute what are we given in the problem. Percent is 28.8%. Then equals, mass of Mg is unknown, so we can write it as X. Divided by total mass, so your total mass is 105 milligrams. This time you need to put the unit, so you'll be guided in your final answer. And then times 100. So the way we approach a problem in percentage, remember that the percent, this percent has to be divided by this 100 so that that 100 will be out. So we need to transfer the 100 from the left side, cancel that, so that your percentage will be divided by 100. So you're left with 0.288 is equal to X over 105 milligrams. So to get X, you know that the approach here is we just cross multiply this. So that's going to be divided by 1. We cross multiply that. So X times 1 is X. And then to get the answer on the right side, it's 0.288 times 105 milligrams. So X therefore, which is the mass of magnesium, is equal to the product of 0.288 times 105 milligrams. And so you will get 30.24 milligrams of magnesium. So finally, we are able to get the answer from the problem of the antacid that contains 28.8% magnesium, and knowing the total mass of the tablet, we can just multiply them after dividing your percentage by 100 to the actual mass of your tablet or your sample. Then we get the mass of the component. So that's how you approach it if the problem will give you the percentage and the total mass. So I hope by now that percentage composition in chemistry is already clarified. Thank you and look forward to the next tutorial video in chemistry. God bless you.